Hello, and welcome back once again. So today I will be, after being off for quite some time, I'm back with another project, and so this session is just an introductory session in which I'm going to explain to you what we will be covering in this project. So this is a comprehensive project, and with this, I've tried my best to work an end-to-end project. So we are starting with the project scoping, then we'll do the data analysis, build those models until the deployment. And with this, I want to try my best for us to actually do a full deployment. So that means Docker, Kubernetes, and all that. So this will be quite an extensive project, and I'll try my best to build an end-to-end project, ensuring that it meets machine learning level a project. So it will be quite intense, and so I hope by the end of this entire journey, we're able to build a project that it will be worthy for our time, and also it will be a project that it's solving uh, a challenge that is actually existing. Okay? So I will be taking you through what we are going to be building. So this is just a scope or an introductory session where we are going to see the project that is of concern, what you're going to be building. Okay? So, like, set some scope on the project. Okay, so I think most of you, if you're watching this video, I think you've tried it one way or another to solve machine learning problems, and in most cases, the credit risk problems, churn problems. Okay, so those are some of the problems that I think you've tried or attempted to solve using machine learning models. And so this is one of those models, but I've tried to incorporate a different spin or a different view on how we can solve these problems. Okay, so let's see what we have installed for today. So of course, we usually build machine learning models or to try and solve a problem. It can be any type of problem. It can be a problem within the business side of things. It can be a problem, let's say, in a customer retention. Okay, it can be a problem on forecasting weather. It can be a problem. Yeah, there are various problems that machine learning. We can use the concept of machine learning to try and solve those problems. So for this one is on the business side of things, and mostly it's going to touch things to do with customer value, lifetime value for the customers, and also a churn risk. Okay, so every business actually will at some point lose customers, and the ones that are win in the grand scheme of things is that those are those businesses that know which customers that they cannot afford to lose. Okay, so we might lose customers, but the businesses that win are those that they have that understanding of the customers that they cannot afford to lose, and so they tend to act before those customers are actually gone. So in this series, I'll be trying to build some sort of a complete intelligent pipeline that combines the customer value aspect and also the risk of departure, the churn as aspect. Okay, so we are trying to see how we can combine these two models into forming a comprehensive model that businesses can use this uh, uh, to actually define customer strategies, retention strategies, and all that. Okay. So the goal in this introductory session is to just explain the problem that we are trying to solve and why the existing approaches tend to fall short or do not actually solve the entire problem, and what it looks like when this project is working. Okay. So in most businesses, again, customers do not generally customers do not call you to tell you that we are canceling your subscription, okay, or they call you to say goodbye. We will no longer be requiring your services. So in some cases, let's say for the retail, they just buy less. Then after some time, they just again buy less of your stuff or request less of your services, and eventually they end up stopping. That means buying goods from your store or even requesting your services. And so by the time that shows up in your revenue report, unfortunately, you will have lost those customers. And so then this problem falls into your retention team, and which in most cases they don't have the finite or do not have the retention team do not have finite capacity, or they might be short in terms of understanding if these customers are at the verge of leaving. So they cannot personally reach out to every customer within your customer database to see who is actually at risk of leaving. So right now, with systems like this, that the one that we are going to build is that, or if they lack such systems, is that they will be either guessing or they will be working from a pure instinct, which is not the right approach for such matter. So the question that we are trying to solve in this case is that it's not whether the customers are going to the question is not whether the customers are leaving, but the question is which customers who, if you're going to lose them, is going to hurt our revenue baseline. Okay, so not every customer within a business they have the same value that they are bringing into the business. So each customer will have a different value. When you're looking at the valuation, they will have different value aspects. So not every customer is the same. And so good businesses will tend to answer this question is that the question that they will tend to answer is which customers leaving us will actually hurt us much, and and within the retention teams, are you spending enough resources to the right one so that we are not losing these customers? So this is about building systems that answer that question precisely, and also it should be automatic. That means we remove the manual processes, and also because this is not a one-stop problem, it should be a continuous process. Okay? So let's look at what the current problem or the current solutions that exist. So the most common approach is to build a binary churn model. I think if you're learning machine learning, this is one of the major problems that we tend to solve. You have a data set, try to build a model for churn. Churn is the departure risk of the customers. Okay, so with churn, it tells you which customer is likely to leave. So churn, which customer is likely to leave. So what's the probability of this customer leaving us? Okay. So the problem with the churn, that one thing that I've realized with churn is that one problem is that it tends to treat each customer um, it's the problem is that it's customer. Let's say a customer spending $50 a year, it tends to treat them exactly as a customer spending, let's say, $5,000 in a given year. Okay, so it tends to treat both customers exactly as the same. So then, when your retention team tends to act on such from the output from the churn model, is that they're just wasting time and effort on customers whose departure won't even hurt much. So they only have part of the problem and not the entire problem. Okay. Now the second approach in most cases will be either doing a sales forecast or calculating the lifetime value of your customers. So maybe in year 2025, 2026, they have spent $5,000. So what is the forecast maybe in the next coming a year? So that is about the second phase. And so this one, you're just predicting how much a customer will spend either requesting for a service or buying from your store. So this tells you information, or it gives you information of how your customer so it tells you who your valuable customers are, but it tells you nothing about if you are at risk of losing them. Okay, so churn is about it treats every customer the same, but again, you don't know the valuation of the customers. If you're doing only a sales forecasting model, it tells you the value of the customer, but again, it does not tell you if you are at risk of losing these customers. So separately, these models gives you only half, uh, only gives information on the half. It only gives you half of the answer. So each model only gives you half of the answer. And so what businesses actually need to do is to know the both sides of the coin. Okay, so who is our valuable customer, and amongst our valuable customers, whom are we at risk of losing? So that intersection between churn and valuation. So that intersection is where the retention team needs to actually focus more. And so that is the gap that we are trying to close with this project. Okay. So as you can see, I've said that we have two sides. So we have the customer valuation, and we also have the churn risk. Okay. So the first thing that we need to establish is the customer value. So when you're looking at the customer value, um, one thing that in most cases that we tend to solve is just to work with the raw figures, okay? Like the dollar amounts that the customers have spent within our store. And so in sometimes it's very hard to work with such values. So giving an example, so let's say we have a customer who is spending like $4,000 for the last year. So is this $4,000 is this high value customer or just an average customer? So without uh, just having the $4,000 from customer X as their spend for this year, with that information, we tend to lose meaning because it's just a raw number. Okay, so by incorporating something to do with the customer value index. So we solve this by predicting a customer value index. So this is the CVI that I was trying to look into. So rather than a currency amount, like let's say for the 4,000, what you're trying to do is that every customer will receive a certain score. So in my case, for example, this is just arbitrary. What you can do, we can start with the 100. So 100 is the base, so where 100 represents your average customer. This is the base score for your customer. So a customer with about 240 or 250, a score of 240 to 50, that means the customer is worth it's about 2.5 your typical customer. So 100 is your base, 2.4, 2.5, 240 to 50, that means that that customer is worth 2.5x your typical customer. Okay, and the score, let's say less than 100, means that that customer is below average. So in by the look of things, this is still a regression problem. We're not diverging away from that. So this is still a regression problem that we are solving, and that the model is learning to predict a continuous number. Okay, so it's just a regression problem that's similar to if you're working on a customer lifetime value problem. But the output, given the output, let's say if you're given, I have the 240 or the 250 value or the output. So in the back of my mind, I'm able to picture this and say that 240 means or 250 means that this customer is 2.5x my typical or average customer. So also another thing is that when you're using such an index instead of the raw values, is that the index tends to remain meaningful over time, meaning that as the spending patterns shift, let's say we have an economic boom. Okay, so the prices definitely will change. We might see that customers are spending more within our stores. And so, but a customer's position relative to the average customer will still be stable, meaning that even if we are using 100 for now, let's say we have an economic boom, maybe it will increase from 100 to, let's say, 150, for example. And so then, if we are able to maintain that dynamic scale, we're able to make sure that our model is able to respond according to changing time. So the customer value index. So this is the foundation of everything you're going to build. Okay. Then the second model is all about the propensity, or you can just call it a churn. So um, looking at the Yeah, mostly looking at the subscription business, churn is obvious. You will lose customers. So this lapse propensity, um, in most cases, when you're looking at the lapse propensity, so we are looking at customers as they are drifting. So they have not left, but they are actually drifting or slipping away. So if you're able to frame this challenge in this manner, it means that we are not trying to win back, let's say, the customers that have already left, but you're trying to identify the customers that are in the process of disengaging while there's still time to act. So that's the instead of churn, we are looking at the propensity for them to churn. So while they are drifting away, we're able to find a mechanism to interact with them and try to stop that process or stop them from actually drifting away. Okay, so the model will read the signals of typical customer that is trying to drift, and then it will give you a probability score, let's say between 0 and 1, and that's what we are going to use to build this model. Okay. So once we have the customer value index, and then we have the lapse propensity, we can come up with the revenue exposure index. Okay, so this will be a value. Will just be, let's say, the revenue, the risk exposure index. So this will be a multiplication between the lapse propensity. So that's the probability score. Then the customer value index. We just do a multiplication of that, and that gives us the risk exposure index. And I think I've shown you the formula. So this is the formula, the REI, the REI. So that's the lapse propensity that times the customer value index. So what this produces is the cost of inaction generally. So a customer with a high value index. So this means this is your high value customer, and also have a high lapse propensity. That means they will also have a high um, risk exposure index, meaning that we tend to lose customers, meaning that a significant revenue is at risk. So we need to act before we lose these customers. Okay. So in a more elaborate way, we can represent this information in form of a matrix. So this is a matrix that you can have. So with this matrix, we're able to sort our customers by risk exposure index. So sorry, that's the risk exposure index. So we have the churn on your y-axis, and you have the LTV. So that's the lifetime customer lifetime value on your y-axis. So as you move or you shift away from zero, that means that you're increasing the lifetime value for that customer. So this matrix, this is what your retention teams will look into, and it's able to sort your customers by risk exposure index. And so, with this matrix, the major concern will be at the top. I say the top right corner, where we have high value customers, and they showing the high propensity to leave the organization. So that's the quadrant that your marketing team or the retention team will have a focus into. They will have to look into that, because if we lose those customers, we tend to lose much revenue. That's the quadrants that you are. So definitely, the strategies that you're going to apply within that quadrant will be different. Let's say from the strategies that you're going to apply for the high value, low churn risk. Okay? So maybe here we can look for maybe upselling or cross selling. For the high value, high churn risk, we might look at maybe discount. Then we have the rest of the cell. So again, having this form of matrix, we're able to assign effort where it's worth. So instead of looking at the low value and high churn risk, we will look into the high value, high churn risk, put more effort, because if we lose these customers here, then we tend to lose more in terms of a business revenue. Okay, so during my research here and there, also I learned that this pattern is it's not just for one industry. It's an underlying pattern within. It's a universal pattern. That means, so in retail you can see that we're able to also look into the same problem. So a high spender shopper whose purchase frequency has dropped significantly in the last, let's say, 90 days 120 days. That's a high customer value. That's high customer value with a high risk, with a rising lapse propensity. So again, this model will work for that. In banking, then you can look at the high net worth individuals or high net worth deposit holders who, in the let's say in the last 6 months, they are not engaging with us. Okay, so that's high value client that we are almost losing. For insurance, the same things apply. For telecommunication, again, the same things tend to apply because you can have customers who are your high average revenue per user. Okay, again, they are showing reduced data usage or whatever service that you're offering. They are showing so instead of buying their usual quantities in terms of service, they are minimizing on that, and so you need to be proactive when it comes to this. Okay. So this is about the iterative cycle of the model that we will be building. So as usual, we are going to start with the data. Data is the starting point. So we look at the data that we have and see how we are able to build this model. So data is the starting point, and every customer transaction, behavioral signal, every interaction will be ingested within the model. So we're able to clean and shape this data into features that we can use for downstream operations. So once you have our data cleaned, then we move to the training phase. So this is where we'll build the two models. So remember, one model is a regression problem, so the customer value index or LTV. So that is a regression problem. And the next one is a churn problem, and that will be a classification problem. Okay, so we'll have two problems, and so that we'll be solving for that. Okay. Then once we are done with the training, we move to the evaluation phase. So we test the model performance. So we assert that the model is performing according to expectation. So all the model performance is measured, the validation, and let's say comparing that against the baseline, um, the baseline with the baseline. Okay. Then we move to that's the evaluation. Then from there we move to the deployment. The deployment. Then from the deployment, the monitoring and governance. That so deployment is all about now Docker, Kubernetes, and all that. So we'll try to go to that extent for this model. Then once we're done with that, the monitoring and governance. So how do we detect the drift? Okay, how do we track performance of the model all day long? Because again, as I said, this is not a process that you build a model today, then tomorrow everything we deploy, then we go on holiday. No, it's something that we need to build, deploy, then track its progress and so on. Okay. So at last, so this is the journey mapping for the success objective. So by the time this system is running, or by the time this system is actually in production, three things will be true. So the first one will be you'll be able to know the value of every customer relative to the entire customer base that you have, and this will be updated continuously. Secondly, you will know which of your most valuable customers are showing signs of disengagement. So before they leave, so with that, you're able to be proactive than reactive. And the third is all about your retention team. Actually, they'll be happy with this because it will be clear and they're able to prioritize action um, instead of so we are taking a data centric approach instead of working from instinct. Okay, so the business impact can be measurable because we're able to increase engagement, boost interaction rates and time spent. Okay, then improve conversion for that. So if you have new products, we will know which customer base to attack with those products. Then we're able to maximize value. We will know which time to spend within each matrix so that we're able to maintain our, let's say, our high value customers, and even if we are working with the low value customers. So what promotions can we send to them in such a way that we're able to keep them engaged? And also other things about retention. So the more you keep your customers, the more you stay in business. Okay, especially the high value customers, because those are the ones that make you stay in business. Okay, so uh, um, so um, so I started with the question. So the question that we started with was, of all the customers are leaving this month, which one can you afford not to lose? Okay? So with this system, as you have seen, combining the lapse propensity, the churn, plus the customer value, we're able to build such a system that answers this question elaborately. So one thing that you have seen is that we are not only answering on the half-sided question, but we are taking a comprehensive look over the customer, ensuring that we know their value and if we are at risk of losing them. Okay? So that's what we will be building on this model. So, so that's it. That's it from me, from my side. So I just took this time to ensure that I was able to explain what we'll be building in this project. And so it will be a comprehensive one. So it won't be a simple project, a change scope, build the pipelines and all that. So I'll try my best to make it to the MLOps level. So assuming that you're an MLOps engineer, what process or steps are you going to take when it comes to such building such a model that you're able to build robust models, models that can be used to make a decision. Okay, so um, as you take time to ponder on what we are going to be building and this model, so just prepare everything and I'll try my best again to build this end to end, so that at the end of this project you will be at the level of uh, MLOps engineers. Okay, so you are combining the data analysis side of things, data science to build those models, then the ML engineers to ensure that you're able to deploy these models, then the MLOps side of things, Kubernetes, Docker containerization, the Kubernetes orchestration of this. Remember, we have two models that we are building. So how can we build an ETL pipeline? Okay, that will take this data, process this data, and let's say store this data within a database. And how these two models will be taking that data from the database, building those models. And again, how are we able to build prediction pipelines? Okay, and how are we able to serve those models and so on. Okay, so it will be quite a rigorous process. So just uh, prepare yourself for this. And so that's it. So that's it for me from today. So if you have any questions, any concerns, or anything, please go to the. You can share those within the comments section, and I'll find time to get back. Okay. So that's it for me today. See you in the next time when we will be starting building the entire model. Until next time, see you.